Hello, I am Satrio Rukmono. I am presenting my study with Professor Michel Chaudron on guiding peer feedback in learning software design using UML. In this talk, I will discuss the background to our study, motivation and related work, our research questions, the study participants and the details of our study, our findings and conclusions. First, I will discuss the background, feedback in learning software design. Learning software design is challenging. There is often no single correct solution to a design problem. Design cannot be tested in the way that source code does, and there are often multiple stakeholders with their own perspectives to consider. In a learning process, feedback helps students learn from their mistakes. Feedback can come from the lecturers or teaching assistants, but can also come from their peers. In one hand, asking student peers to give feedback forces them to think deeper on design, including their own. In another hand, sometimes novice feedback can be considered harmful. Here are some known facts that motivate our study, discovered in related work. There are difficulties that students face in abstraction and identifying responsibilities of software elements. This serves as a base motivation for our study and to explore the ways that we can help students in this regard. A study found that UML modeling triggers design thinking. Corresponding to the previous point, UML provides notations to describe abstractions and responsibilities of software elements. This justifies the use of UML in a software engineering classroom setting. A good UML diagram layout helps students understand their model and provides better insight to evaluators. This fact influences how we design our study. As you would later see, the layout of diagrams is one of the major aspects that we ask students to give feedback on. Another study mentioned that when assessing design diagrams, students focus primarily on semantic elements in the design instead of syntactic elements. This provides a clue on what to look at when doing analysis on peer feedback in our study. Based on this, we formulated the following 3 research questions. First, what type of feedback do students find helpful in learning software design? Second, how to instruct or guide students to give good feedback? And lastly, how do students use the feedback to improve upon their design? The subject of our study is the third-year course for bachelor students at the School of Electrical Engineering and Informatics, Institut Teknologi Bandung, Indonesia. In the course, students are given lectures on software architecture design. They are divided into groups of 5 to work on software projects using agile methods. Around halfway through the project, they are asked to give feedback on their peers' designs by completing review forms. Upon receiving feedback, each group responds by completing a response form. I now switch to a visual representation for more details on our study. As mentioned earlier, we have groups of 5, where each group delivers their design document. After the third iteration of their software project, each project group is then split into 2 reviewer groups, with each reviewer group being asked to review 2 design documents. This means that each design document receives 4 reviews in total. This review group's arrangement was designed to further mitigate the problem of harmful novice feedback. By giving feedback as pairs or a group of 3, there are warranted discussion in the process that we hope to stimulate deeper thinking and increase the overall quality of the feedback. The original project group are then asked to select 2 most helpful reviews and give their responses to each of them. By this process, we also hope that students would exercise some criticism to the reviews and weed out the bad feedback. Here are some details of the review and response tasks that students need to perform. The review or feedback form contains questions on the visual appearance of diagrams, on class and method naming, on design quality, and on document clarity. The response form contains questions on how they would improve their design in each aforementioned category and on the feedback clarity. In the next few slides, I will show you a selection of analysis on the reviews from the students. This is the comments that students give on the visual appearance of diagrams. In the question that generates this feedback, we mentioned three aspects that students may consider: line crossings, spacing, and alignment of diagram elements. In the comments, students mentioned those aspects mostly as negative comments, like consider lines, consider spacing, and consider layout. We can see that the corresponding positive comments are few. The positive comments are mostly delivered using generic words like good and neat, without mentioning specifically which aspect of the diagram is good. Other than those three aspects that were hinted in the question, we can also see that some students find their own aspects to pay attention to, including text size, diagram size, and a specialized form of alignment that takes component hierarchy into account. Moving on to naming, here are the comments that students make on class and method names. Like the previous questions on visual appearance, in these questions, we mention specificity and descriptiveness as factors that determines the goodness of names. However, contrary to the comments on visual appearance, students mostly use these characteristics in positive comments: descriptive and specific. Descriptive and specific. The students seem more critical when commenting on bad names with more vocabulary, such as reflects implementation detail instead of conceptual, follows a certain convention, or is consistent, among other classes or methods. It might also worth noting that quantitatively there are way more positive comments than negative ones on class and method naming. Next up, in the questions on design quality, we grouped the students' responses in this chart. We have questions on decomposition, class responsibilities, class role stereotypes, and whether there is enough description in natural language. In this chart, the rectangles that are aligned vertically represent the same group. So for example, the leftmost group received all good comments on all four aspects, and the rightmost group were met with more negative nuances of comments. From this visualization, we can take away two messages. The first one is that students did not seem well versed in role stereotypes, that none of them are confident enough to give a firm no to this question. And the second one is that there are groups that did not understand most of the aspects depicted here, like this group, and these two groups, which could be a good diagnostics for the teachers. How did the students respond to these reviews? Here's an overview of what students say they would do in response to the feedback they received. Each diagram depicts a group's willingness to improve their design in a certain aspect in three groups: naming, responsibility and decomposition, and presentation. On the y-axis, we divided the groups into categories of will revise, represented by the purple boxes, and will not revise, which is the orange boxes. The x-axis portrays how bad they were performing in this particular aspect. Although they use different units, for example, for most of these charts, the x-axis are labeled percentage of negative remarks, and another, the number of classes with incorrect stereotypes, or the number of components representing implementation concepts. They are all laid out such as that the better performing groups are placed more to the left of the charts or closer to the origin point. We would expect the purple boxes, those who plan to revise, to be located more to the right side of the charts, since it means that they receive a lot of negative feedback and thus revisions are needed. Conversely, we would expect that the orange boxes are located more to the left. The students performed well and may not feel the need for further improvement. At a glance, these expectations are generally met. We can see that indeed the purple boxes gravitate more to the right compared to the orange ones. The best example for this is the charts for class names. Most groups that say no received 0 to 20% negative remarks, and most that say yes to revision receives 20 to 60% negative remarks. However, we can also see, for example, in method naming and the existence of implementation concepts in the structural view, that sometimes a group with lots of negative remarks do not intend to revise their design. On the other hand, there are also a small number of groups that plan to make improvements even when they did not receive any negative feedback, like the ones here and the ones here. This might be an indication of how motivated these groups are in doing the assignments. On the clarity of feedback that the students received, 90 of them stated that the feedback was clear because the reviewers gave clear explanations, examples, and elaborate suggestions. The 10% that says no mentioned that it was the lack of explanation that made the feedback unclear. These responses give a clear picture of students' preference on feedback. Upon thorough analysis on the data, which parts of I just presented, we devised our answers to our research questions. For the type of feedback that students find helpful in learning software design, we found that students prefer explicit positive feedback, or in other words, that the lack of negative feedback does not equal to positive feedback. This aligns with many research findings in the field of education. Students also found value in feedback that mentions specific examples, and we also discovered that it is better to have separate feedback on syntax and semantics. I mentioned earlier that an earlier study found that students tend to look at semantics when giving peer feedback. However, we found that students may not yet possess the required experience or insight to give the best semantic feedback. As such, a separate prompt on syntax and semantic feedback may prevent a mixed review aspect and quality. For the second research questions, how to guide students to give feedback, we formulated the following guidelines. First, we need to encourage the reviewer to provide both positive and negative or constructive feedback. Second, we may need to use refined feedback questions instead of asking for general comments. For example, we can specifically ask about the layout, spacing, and legibility when reviewing diagrams instead of a generic question like give your comments on the diagram. We will see more examples on this on the next slide. Next, explicitly ask the reviewer to mention specific instances and, when relevant, provide counterexamples. Lastly, we suggest that the use of quantifiable software design aspects such as diagram layout and class naming to approximate overall design quality. Here's an example of refined feedback questions. In our original review forms, we had these three questions. Are class names easy to understand? Are class names specific? And additional feedback on class names. Based on our guideline, we would revise the questions as the following. Ask the reviewers to mention classes with good name and for each, the reason that it's good. We can prompt the reviewers to use the vocabulary that we discovered, such as descriptive, specific, reflects its responsibilities, and follows a convention in their reasons. In this question, we explicitly ask for positive feedback with examples. We can then ask for the corresponding negative feedback to mention classes with bad names and their reasons. Lastly, for our third research questions, how do students use the feedback to improve their design? We found that in general, students' plans of improvement are mostly as expected. They have plans of improvements in aspects that they are lacking. However, The amount of effort students was willing to give in to the assignment is also visible from the data. We found that the best performing students plan improvements despite a lack of negative remarks in certain aspects, while poorly performing students made little to no plan of improvements in some aspects. To conclude, we repeat the key points of our answers to the research questions. First, students find value in positive feedback with specific examples on syntax and semantics. Second, we need to give very precise or directed instruction for points of attention in the feedback and ask students to explain the rationale behind their feedback. And third, we found that good students improve while poor performing students not as much. This is the end of my presentation. Thank you for your attention. And if you have any questions or comments, you can get in touch through these email addresses.